we can start by taking any two lines, and you can put them anywhere in the plane. We're going to draw them such that they look perpendicular, and then we're going to prove that they are. So I can start by putting them here, or I can move them here or anywhere I want to. But for the purpose of this proof, I'm actually going to make it more simple by making them intersect at a right angle, or what looks like a right angle, on the origin. Then we're going to label this point 1. And we're going to create a triangle, which would be the hypotenuse, assuming this would be our right angle, since these two lines are supposed to be perpendicular. And so we would now have 3 vertices of our triangle, and we can even go ahead and call this the origin 0, 0. We're going to label this point has an x-coordinate of 1, and we're actually going to label this y-coordinate as m1, since m1 would be the slope of the purple line, and it's the change in y over change in x, which if the change in x is just 1, then it would just be m1. Down here would be m2, 1 and 2. So what we're going to do is use the converse to the Pythagorean theorem to show that it holds true, and if it holds true, then this must be a right angle. Okay, so that says that if a squared plus b squared equals c squared, then the triangle, or a triangle, it has a right angle. So a and b would be the legs, and c would be where the hypotenuse would be. So this would be our a and our b, and we're going to show that when we square those lengths, and then that it's equal to the sum of this one squared. So we're going to start by calling this side, the length of this side would be the distance formula applied to these two coordinates, so 1 minus 0 squared plus m1 minus 0 squared, and then the square root of that. And then down here you would have the same thing, only you would have m2. And then this length here would just be m1 minus m2, or you could call it m2 minus m1 because you're going to square it. It doesn't matter either way. Now when you go to set it up, this thing squared, the radical will come off, so you'll just have what's underneath, which is really just 1 plus m1 squared. Plus this green side squared will look like this. And then this thing squared, so m1 minus m2 all squared. So combining the left and then distributing or foiling out this, you would get m1 squared minus 2m1 m2 plus m2 squared. These will cancel since they're present on both sides, so you have 2 equals a minus 2 m1 m2, dividing both sides by a minus 2. Now gives us that the product of m1 and m2 is equal to negative 1, which is exactly what we were trying to show.